Morning, everybody. So it is Friday, and I apologize. We're about 10 or 15 minutes late on this webinar, working with the awesome folks over at Treatstock to get it connected back onto the show. So I apologize there, a little technical glitch, but we wanted to make sure that we had the presentation available so that we could share the screen and have a little bit more content there. So I like to be as interactive as possible with the YouTube Live. It's a little bit new for me, quite frankly. Usually do a little bit different webinar series, but it's been a learning process and definitely has some really awesome features. So feel free to comment in the YouTube live stream if you're able to do that, and I'll definitely try to be following that along and answer any questions that might come up. So without further ado, I'll just kind of introduce myself and iSolids and what we do. And then this presentation is ultimately about applying color into the engineering process and how new 3D printing technologies can really help provide a lot of external value that might not be perceived up front. And so, yeah, I'll jump into that. And we are, of course, always available for any questions that might be followed up after the presentation. So awesome. So a little bit of the agenda here quickly is I'll provide a quick introduction, of course, about me and self, and then we'll get into a little bit about additive manufacturing for any of the folks that might not be quite aware of what that means. And then we'll go into the color design and why you would use that. And ultimately, we'll go into some practical applications. I think that's where the bulk of the presentation I'd like to provide would be centered around. So. All right, so a little bit about me. I'm Kason Knight. I'm from the Houston, Texas area. Went to Texas A&M, got my mechanical engineering degree from there. Eventually went on to Georgia Tech to get my master's in mechanical engineering from there. So we are a pretty highly technical, type of. We're not in regards to 3D printing services. We're not just a one-stop shop in regards to you send your model and we kind of put it on a 3D printer and hope for the best. We like to actually look at individual models, and because myself and the rest of the team are all engineers or some sort of technical degree. So yeah, a little bit about my background. I originally started off in oil and gas and worked in research and development, and spent a couple different, years doing various tasks from field engineering, application engineering, research and development engineering. So it's a pretty diverse background that was very helpful, and it led into the 3D printing 3D printing desire that we had, because in my opinion, 3D printing has all of these amazing facets. It has electrical engineering, it has mechanical engineering, it has design, it has software. So all these fun aspects are kind of combined into one technology. So the hobbies of mine, I've got an amazing family, 2 kids, awesome wife. And so spending time with them is of course very important for me. Just technology in general. I'm the kind of geek guy that just loves to get new stuff, see what's new available, following things like SpaceX and Tesla and all these Apple, finding out where new technology can be applied into new areas that we've never seen available. So aviation is another major hobby of mine. I definitely love to fly. I got my pilot's license a few years back, and it's very free feeling. So that's what I like to do in my free time, and just being outdoors and doing a bunch of sports and things like that. So interesting fact is I am colorblind. A lot of people think that's kind of interesting just because I'm giving a presentation about color. So all right, so iSolids and what we do, as I kind of suggested, we're an additive manufacturing or 3D printing company. We specialize in prototyping and on-demand inventory, as we call it. And what that means, on-demand inventory, is we'll have a digital log or digital archive of various parts. And rather than having to actually have a physical inventory of shelves and products that cost money to store, may or may not be used, all sorts of costs associated, this new 3D printing technology where we can print fast, high quality end use parts allows us to basically just digitize that entire process and on demand. So that's what that means. We also do small mid-volume production runs and even large volume depending on the type of application and the part. We're currently working on a project that is approximately 22,000 parts that we've been producing on the FDM technology for about maybe 2 months. So that kind of provides some scale that we can help with. We utilize the three most common 3D printing technologies, which is of course fused deposition modeling, which most people are familiar with. That is the more consumer-based 3D printers. Basically, just build layer by layer, building up by melting a plastic spool. We also use stereolithography, which provides ultra-fine details using a laser base and liquid resin. And last but not least, we also use multi-jet fusion, which has only been released about maybe 3 or 4 years ago in the first technology first release, and it's really catching on in the last 1 to 2 years. And this is actually the technology that we have in house that applies the full color characteristics and allows us to get some pretty amazing parts. So uh, in addition just to 3D printing, we also provide engineering services, which are very much, in my opinion, coincide with each other. I think what makes us good at 3D printing is the fact that we do engineering, and what makes us good at engineering is the fact that we do the manufacturing side and the 3D printing side as well. Um, some of the services that we provide there is just product design, engineering, CAD modeling, animation, FEA, CFD. So basically any facet of the engineering realm. We also have just recently brought on a virtual and augmented reality side of the engineering, and that's been pretty cool. So what that allows us to do is actually provide virtual reality environments so that we can do training simulations or even just product testing before we actually 3D print it. So that's been a lot of fun lately. So I do like to know about the audience, and I'm following along on the live stream here. And if you can or you're available, I'd love for you to just kind of say hi in the chat and let us know who you are and kind of what your experience level with 3D printing might be. That would be awesome. So, um, well, I like to start with this slide that says, "What is 3D printing?" And this was my first experience with 3D printing. This was well, I take that back. My first experience with 3D printing was actually back during my bachelor's degree. And at that time, we had at Texas A&M, we had a Stratasys machine that was very expensive, 6 figures to just have the equipment. And this wasn't all that long ago. This was 12, 14, about 14 years ago. And this will tell you where we've come in the industry just within basically 1 decade. So that was a uh, roughly $250,000 machine. Did some pretty amazing parts, but it was very expensive to operate, and it was not by any means accessible to, I would say, consumers or even a lot of professional companies. Uh, this right here was approximately 5 years after that first experience when I bought my first 3D printer and had it in the closet in the home. And there was just a passion that grew with it. I knew what it could do, and it was awesome to see how the same technology just drove down cost and made it accessible to a lot more people. And that just really sparked something. And I thought, well, we'll see what else we can do. And so this is when I would call my beginner phase, where I definitely had more machines. I kind of knew a little bit about 3D printing, but I found that the more you learn about something, the more you realize you don't know a lot about whatever that subject is. And that's just part of, gaining experience. And that's kind of where I was in this phase. I knew just enough to kind of get things done, but there were still a lot of lessons to be learned. We continued to grow, and this is what I would say my intermediate phase. And we are, this is when I took the company full time, and we were really creating a 3D print farm and realized the scalability and the accessibility that we could provide by just taking the same consumer FDM technology and really, really growing it up to higher volumes. We continue to grow. Very fortunate, and we built out our 3D print farm. This picture taken approximately about a year and a half, maybe 2 years ago. We originally purchased or acquired a small workshop and quickly outgrew it, and had to acquire the building next door and cut a hole in the wall and grew into that. And it wasn't very long that we eventually had to look for our own, dedicated building. And we're glad to say that we did, and moved approximately about a year ago. We moved into this new facility and quickly filled that out. And even since some of these pictures were last taken, we've definitely expanded even more and more equipment. So wouldn't be surprised if we're out of space again. You can see the demand, you can see the application and how 3D printing can be used in so much more than what people originally thought it for, which was primarily just prototyping. It's definitely a suitable technology and cost effective now for high volumes, and that's where we can definitely help out. Um, so what is additive manufacturing? Just a very brief overview. I know a lot of our audience will most likely have a lot of experience in 3D printing already, but the way I kind of view it is just breaking it down to its fundamentals. It's any process in which material is joined or solidified layer by layer to generate a three-dimensional object. And so when you look at that and compare that to other manufacturing technologies like CNC machining, for example, you normally have a block of material and you're removing material away, which generates a lot of waste with all the material you have to remove. And that's one of the basic fundamental benefits of 3D printing is rather than removing a large portion of material, you start with nothing and you add that material as needed. So there's generally less waste. You can often do more complex geometries that you can't obtain with other manufacturing methods. And you have the speed and the flexibility that comes along with that technology. So when we look at, I mentioned previously, we have fused deposition modeling, stereolithography, and multi-jet fusion. The one commonality amongst all three of those technologies is you take a layer or you take a three-dimensional object and you cut that object into individual layers and you process those layers on top of each other to ultimately build it out. And the beauty of that is you can create different speeds, different accuracies, different resolutions, different properties by adjusting the height of those layers as well. So why would you use additive manufacturing or 3D printing? A lot of it kind of just mentioned in regards to the theory of it, but it's design freedom, rapid production. You can do on-demand inventory, less waste. One of the best benefits, in my opinion, is there's zero upfront or tooling cost. When we compare that to traditional methods like CNC or really trying to highlight the injection molding, if you're talking about the plastic side, there's often an upfront tooling cost that can range anywhere from a couple thousand all the way up to hundreds of thousands of dollars, depending on the complexity of the part or the number of parts that you're working with. So the benefit of injection molding, once you've created that tooling, is the per part cost is very, very low. However, with 3D printing, our per part cost, generally speaking, might be a little bit higher, but we have zero upfront cost. So looking at this graph right here is a pretty great example where eventually those two lines might intersect, and the blue line represents the injection molding process where you have that high upfront cost but low per part cost. And the additive manufacturing is the green line there. And that where those two lines intersect is ultimately called the break-even point. And we often discuss with our customers and try to show people that when you're producing maybe a couple hundred parts, even though it might seem more expensive, your overall cost is going to be much, much lower. Now, one of the other factors that goes into play here is the fact that after you create your tooling cost using injection molding, you're kind of locked into that design. So if you want to make small iterative design changes, it becomes very expensive because you basically start over. With 3D printing, that's not the case. If you want to make a very, very small incremental design change after you've produced maybe 500 or 1,000 parts and gotten feedback on that, you can easily change that part and just continue production. So that is a very, very big cost savings to a lot of environment, especially in an environment like right now where things are changing very fast. New ideas are coming up and being developed and going into market right away. And so that's the I think the effect of the information age as we can consume faster, we can also develop faster. So. All right, so now I'm going to jump into the bulk of the conversation here, which is why add color? Why do we need color when we talk about 3D printing and production and manufacturing in general? Well, I think aesthetics, we look at the image on the left there, one of the key components is just making what you're doing or what the part that you're producing look so much and appear so much more professional just by adding color to that product. This is not an uncommon practice. We see this everywhere. There's obviously a very good reason why when color television was developed, everybody switched to color television because people naturally, we live in a colorful world. We want to represent ourselves within that colorful world. So aesthetics is a major factor. One of the others is just visibility. Again, one of the other reasons we're driving down the road, we see signs that are very, very bright and vibrant colors. We see signs that are very contrasting in color, and the reason is that it stands out. We use color to our advantage to highlight a particular component or to give emphasis to something that would otherwise be, I guess, lost within a sea of other visual cues. So visibility or applying color in specific situations increases your visibility, which can be very important for a lot of different design features. And one of the others is simply communication. There's been a lot of studies around how color is used in very strategic applications to communicate a certain feeling or emotion. It's in when you ask somebody, what's your favorite color? And they represent that color back. And there's also been studies that say that people's color preferences are often equated to a lot of their personality traits, which is interesting when you really kind of get into it. It's more theological or psychological aspect of it, but it does remain true, and you can see it a lot in advertising. For example, on this little graphic here, we show that red is passion, aggression, danger, appetite. So red is often used to show very bold, um, very bold products or very bold companies even. So you use it like a company that might want to show, we'll use Coca-Cola, for example. It's a very bright red can. They want to show that it's appetite, for example, using that one. They want to show that it stands out amongst other colors that might be more dull, and it shows a very common, or it shows a very strong uh, appeal to it. It'll definitely stand out more. Using some of the other ones like blue, for example, when we think of blue, the blue sky, we think of relaxing, we think of the sea and very calming things. So that tends to relate to more natural settings. Um, so yeah, we definitely go on topics of all these. And what I found when I talk to people about this particular component, there's a lot of different opinions. Like, well, I don't feel that way with that color. These are very subjective, no doubt. But there's a lot of studies that revolve around it, and it's at least something that definitely needs to be paid attention to. So, all right, well, we can talk about how or what color does. Now, the next question is, well, if I'm a product designer, or if I'm an engineer, or if I'm a marketing person, and I know the importance of color, and I want to apply color, but how do I do that? Well, in a lot of traditional methods, the first and most common thing is, well, I'm going to paint it. I'm going to produce this part. I'm going to make this part. I'm going to do whatever I need to generate this, and I'm going to apply paint in and do it that way. That's a very easy way to do it. Most common. However, it gets complex when you talk about a lot of different colors or a lot of complex geometry, where simply applying paint becomes very expensive or sometimes even impossible to do. Like me personally, we've painted components. There's a good example of it right there. That's a illustrative uh, graphic for a trade show there, and we had to paint all of that yellow body, and it was very, very time consuming. The results turned out really great, but at the end of the day, a lot of that cost involved in that particular project was not with the 3D printing or the actual assembly, but it was the painting side. That was the most expensive component. So other ways to do that is decals and stickers. We have another example of a project there where we wanted to apply some text onto a part for some visual representation, and we just applied some stickers onto it. And that's a very, very quick, easy way to do it. But often the feedback we get that stickers are not very durable. For one, they can easily fall off, and it often just kind of looks cheap. Um, there's just not a lot to it. It just kind of looks like an afterthought. Uh, one, I don't have a graphic, unfortunately, that we could show due to non-disclosure reasons, but hydrographic film is also a very cool way to do this. And people might have seen like various short clips or videos of what hydrographic film is, but it's when you have a bucket of water, I guess you could say, and there's this film laid across, and you'll see the part being dipped into it and come out with a really cool graphic. Hydro dipping is another common term for that. That is a really cool way to do it. The only thing is it's not very repeatable. You're going to get a little bit, you can't always dip it in the exact same spot. Your graphic is going to come out a little bit different shape or geometry each time. amazing results, very durable, and has a lot of pros to it. It's just normally repeatability and cost that are downsides to that. Etching is another one, kind of like stickers. Like etching is literally just engraving within your part. So you're kind of embossing or debossing into your part the text or logo that you might need. That's a very common practice to build into designs themselves, especially in 3D printing. So, for example, if I wanted to add text, I'll just kind of cut into the body of that text and I can see it a little bit. But what you have there is you have depth, but you don't have contrast. So if you're looking at the part directly straight on, you're kind of dependent on shadows to give you some of those depth cues in order to read or see the logo. And of course, you basically have it's a binary type approach to it. So you either have it off or on in regards to that voxel, and so it doesn't give you a lot of flexibility, but it is very low cost, and especially with 3D printing, you can integrate it directly. So. And of course, 3D printing. Now, what we're talking about there is 3D printing the color directly on, and that's of course the bulk of our topic here, where we're evolving and trying to get this presentation to really show some value. And I'll jump into that. And I do have a question mark here because there's a lot of other ways and unique ways to do it. These are just some of the most common ones that we've come across. And so, if you are interested and have the ability, just go ahead and enter a comment there if you have used or are familiar with any other ways to apply color in the manufacturing realm. All right, so quick discussion here on the benefits of color integration. And again, a lot of this has already been discussed in just the introduction as we kind of go into what we can do. But just to kind of drill some points home, some of the main things, of course, supplemental replacing otherwise costly, time-consuming post-processing. Again, using the example of the large trade show piece. Increased durability. Again, going back to the stickers. The stickers easy to come across, especially if you're just kind of tweaking with it or have even a kid or somebody just wants to kind of pick at it. Better design freedom, not limited to just that embossing or debossing approach. You can apply colors on the logo, for example. You might be able to cut the logo in to get the shape, but you can't get the intricate details of the colors that ultimately convey a message that you might want to convey. And last but not least, this is one that we haven't really talked about yet: production scale. This is important because we might be able to produce something and do it effectively when you're doing 1 or 2 or 3 parts. But the cost of scale eventually becomes a problem, just because it might be time constraints. We might be able to produce something using paint, for example, but if it takes 4 hours per part and you want to produce 400 of them and you need to get it done in a week, it's simply not possible. And so it removes that as an option. So that's one of the other main things to keep in mind as well is your lead times, your production scale, and where you ultimately go. And I want to pause here for just 1 second and kind of promote the idea of whenever you're even going through the prototyping phase, not to just think about what can be done during the prototype, but what can be done after you're done with that. Design for manufacturing. You want to think about the process that comes next. And we see that a lot. That's why I wanted to pause and mention that, is because we get a design that might work great even within the 3D printing technology we're using for prototyping. But one minor change when you go to the next step, whether it be injection molding or CNC or whatever that might be for your application, it really changes a lot. And being aware of that up front and not trying to force it one way for the prototype and then go another way for the manufacturing method, that's definitely something we can help out with. So, all right, well, what technologies are out there in regards to full color 3D printing? These are some of the most common, so I just wanted to kind of show what's available. Really low cost and becoming more popular is just embedding 3D print or color within FDM print. And that's often by combining multiple filaments or cutting and splicing different colors of filament and building the model that way. Some of them are, the one shown here, for example, is a Da Vinci full color 3D printer. They're pretty awesome part, and actually kind of literally prints the color directly on top of the layer of the filament. Another one out there is something called the Mosaic Palette 2, which is a component that basically you feed it 4 different colors and it'll cut those colors and apply them at certain locations. Using FDM in these types of ways is is generally low cost. The challenge is often speed. FDM, if you want to produce tens or hundreds of parts, can be challenging. And repeatability and reliability are probably the biggest concerns, though, based on our experience. FDM is just generally a um, a relatively labor intensive process, and especially when you add the extra complexity that is involved with color. So, for example, if we print one part in white, well, we have one spool, and there's things that can go wrong with that spool of filament. But when you're feeding four spools of filament, then there's a lot of extra potential for something to go wrong. So it just increases the complexity substantially. One of the other ones in the middle there, that is a 3D Systems um, project. And what that does is it has a powder based system that kind of produces the part and you can build it up. And so it's got a little bit of a granular finish to it. Amazing color replication. The only downsides is really cost to introduce. I mean, that's a industrial, professional, or commercial grade 3D printer. So it's just accessibility. It becomes a problem. But really, the downside, and this has been out for a while actually, but the downside to this is it's very fragile parts. Usually a gypsum or some sort of natural material like that, and it's just you have to handle it very very delicately. And normally you apply like a surface bonding agent, almost like super glue. Like you basically dip it in super glue to kind of harden or strengthen it. So it's a kind of complex process, makes it expensive, but mostly it's just the strength. And again, the parts that come off this are usually really, really aesthetically nice, appealing parts, but the strength becomes a concern. And so, generally speaking, we only recommend something like this for cosmetic features or trinkets or things that won't be exposed to maybe an end use application. The next one shown there is something called polyjetting. That's a Stratasys technology, and it's very, very, very cool technology. It can do amazing things, awesome surface finish, amazing color, smooth. You can't see layer lines. It generates a really cool result. But in doing so, it's an extremely expensive process. Um, Not many people offer it because the demand for paying such a premium generally goes down. You can't really do it in high volumes and some of the other things that go along with it. So just generally speaking, though, the cost is a factor there. So with that being said, when we got into wanting to bring on a full color print 3D printing technology, we looked at some of these options that were readily available, and we were kind of drawn to the kind of the new guy on the block, which is multi-jet fusion. And HP about a year and a half ago released the HP 580 machine, which is their full color version of multi-jet fusion technology. And a little bit about what multi-jet fusion is. It's powder based, kind of like SLS or selective laser sintering. But the difference is in selective laser sintering, you're using obviously a laser to actually bond or create the two-dimensional images and kind of fuse all of the powder together. In multi-jet fusion, it's a little bit more of a complex process where you apply agents and then apply a high energy source by a basically a high energy lamp. And then that energy lamp chemically with the agents themselves actually fuse the part and separate it from the powder. There's a little bit more complexity. You have something called detailing agents, and you have fusing agents, and there's a lot of thermal properties that come into play. The process itself seems relatively straightforward, like a 1 or 2, 3-step process, but the implementation is very difficult, and HP has done a pretty good job of that. Here's some specs on the machine itself. We can produce basically 3,000 centimeters cubed per build, which that's a theoretical limit. Normally don't go near that just for reliability's sake, but it still shows the power and the speed of the multi-jet process versus using the laser. And it's roughly about a third the operating costs of a lot of the other technologies that are out there. So those are the main drivers for us. It was very good quality results. It was much faster, and our main core business is production volumes, and it's 1/3 the cost. And so it kind of hit all the main bullet points for us. The only downside, quite frankly, since we got the technology, is it's so new that there are some hiccups and bugs, as would be expected. But I will have to kind of give a congratulations and a thank you to HP, just by firmware upgrades, minor hardware upgrades that since we brought on the technology about a year and a half ago, the results have been phenomenally improved. Reliability has gone from about 60 to 70% up to about 95, 98%. So the technology has evolved substantially, and it's been really good. And that's why we're excited to share what this technology can do now. I'll see if this will broadcast. There might be some latency issues, but this is a quick example of what multi-jet fusion process looks like in real life. So you can see this is a one-time speed. So this is not sped up or altered in any way. This is just a direct video. Powder is applied, agents are applied, and then the fusing is completed. And that's how fast multi-jet fusion is. And that's the real value that it provides. Hundreds, generally speaking, for example, to provide some scale, we have several industrial production versions of the multi-jet fusion technology, which is referred to the 4200 and the 5200 series. Those do not provide color, but just to kind of get some scale, we usually produce around 450 parts every 16 hours of printing. That's the average for us. So it's pretty amazing. Okay, so here's where I really hope that people are staying with us and where we can maybe share some really great ideas in this presentation. This is kind of the bulk of where we want to be. So for the next few slides, I'm going to talk about where are some ideas where we might not have been thinking about applying color that are really good ideas. And we can't take credit for a lot of these. A lot of these are customers or other folks that we've shared ideas with. And so, but this is where we've seen it really get applied in really cool ways. So the first and foremost is novelty in art. When we think about art, color is a major component of that. And 3D printing has been a really cool way for artists to create three-dimensional models in ways that they've never done before, using all sorts of cool animation and design software. And when you apply that color component, it just takes it to the next level. So applications that personalized gifts and theater props, custom decor, memorabilia. And we've just got some examples of things that we've done here in-house. Just little toys and trinkets, and you can see the accuracy in the color replication that can be obtained. When we talk about memorabilia, we can do 3D scans extremely fast and efficiently these days. And in fact, many people may not know this, but depending on what kind of cellular phone you have in your pocket, you can often do a 3D scan that is of very high quality these days. iPhones are able to do it. I personally have a Galaxy Note 10, and with this particular phone, we generated this 3D scan of one of our awesome, valuable employees here. So took maybe 10 or 15 seconds, zero post-processing. We didn't alter this in any way. And we immediately sent it to the printer just to see what we could replicate. So that's an awesome way to do it. And the reason I mentioned that real quick on the 3D scanning is most people think, well, man, this is going to be complex. I don't have the hardware. I don't have the knowledge. I don't have the resources or the know-how to kind of generate some of these really cool full color designs. There's definitely ways to do it. It's much easier than most people think. And we'd be happy to talk about and help with that as well. So industries where this might apply, obviously photography, fashion, film. We've seen it in sports. That's been really popular. People want to, like it's often, you'll do a photo session, showing a sports team. And now you can create a three-dimensional figure with very easy hardware. One other pause there while we're on the topic, photogrammetry. That might be a technology that many people aren't aware of, but it's actually software. And you can create a high quality 3D image with just a series of pictures. The software basically analyze the pictures, it'll orient where those pictures were taken in space, and it can create the 3D model for you. There's even some free versions of the software that are out there. So that's another thing. All right, so one of the others is just functional requirements. There are applications or designs that simply need, in order to perform the tasks that they're designed to do, they need to have some sort of color or contrast or detail or any of that type of thing. So this is a very easy example for us to talk about. This was a counter wheel. It was being injection molded, and then they were applying additional color and the text on top of it. Perfect example of what we are talking about previously, where this was being done, but the post processing cost of it were far outweighing the actual cost of the part itself. And so we were able to apply color directly into the print, and it's one, it's more durable. It's not going to scratch. The color is physically embedded within the part. So, I mean, you're not going to scratch or pull the stickers off or any of that type of stuff. It's great for color matching. Say you have a component and you need to, it has a red shell and you want to add a part to that and you want it to be red as well. Well, we can do that. We just apply a simple color directly to your part. You don't have to worry about painting and clear coating and all that other stuff. Really, consumer products, I think, are the main drive for what I would say functional requirements of color. And yeah, this is a topic that we've seen, but it's often hard to convey because normally we don't know. There's not a lot of things that we think, oh, this will happen. We see it and then we know that it can be applied. I know it's a weird concept, but this is a good example. Originally, when we got this particular project, we saw the idea and we printed the part, but we didn't apply the color towards it. They were still putting the same sticker, the same application on it. It wasn't until after we realized that we don't need to do that. We can go ahead and skip that middle process. So I guess what I'm trying to say there is it's hard to tell you where this will happen. Often the application will tell you when it needs to be applied. This is one of my favorite applications of full color is what I would call technical modeling. This is really good for architectural and construction projects where you want to show visual displays. A lot of that, I remember back during my college years where you would definitely know the architectural students as they're walking across campus because they just have briefcases and toolboxes full of tools to create these very complex displays. And now I think about what we can do with just the 3D print and it's ready to go. And I can only imagine what they could do with that back then. So these are just some pretty cool examples. Some of them are actually provided by HP there on the bottom, showing some anatomical or medical models. We have a bracket there that's been applied with an FEA, and then the FEA results were overlaid on top of the part itself, and being able to print that out and actually physically see it. And that'd be great for structural failure analysis, or even just obviously during the design process to prevent structural failures or any of that type of stuff. It's a very cool display, and you can get an actual sense of what's going on there. Training aids as well. That's another thing we've seen. We actually work with some various medical, and they actually produce parts that have the color applied to give it a more realistic feel to it as they're going through various training operations. So industries on this particular one could be boundless, but some of the ones that we've seen is construction, architecture. Geology is a cool one. We've seen where people will do topographic maps and being able to not just, that's very common in 3D printing in general, doing FDM topographic maps. But when you add the color to it, it just takes it to a whole new level. Medical and dental is important. Technology just in general with the training aids, and museums, of course, as well. So this is, I would say, the most obvious and probably the most practical way of applying color. When we think about, like what we talked about earlier, that these different colors are designed or naturally illustrate different feelings and emotions. And when we talk about brands and logos, that's exactly what those are designed to do. Is they're designed to illustrate a feeling or emotion to drive a consumer towards that particular product. So this is a very easy way. Like if you have a product and you want to take it to the next level, well, just put your logo on it. Well, that's easy when you talk about stickers and all these other things, but for all the same reasons that we've already kind of mentioned, when you can embed that directly into the manufacturing process and you can get that same result, it's just much more powerful. And there's a lot to be said about when somebody gets a particular product and they don't know how it was created or what that even is. It shows a sense of professionalism. It shows a sense of curiosity and wonder. And that's what we've been able to do with a lot of these 3D printed components with logos built in. We just have some examples of our own stuff for non-disclosure reasons here, but there's a lot of power that goes along with that, and I think it kind of speaks for itself. I don't think I necessarily need to go into a ton of detail on it, but just seeing some examples and where to put that, I think, is what provides a lot of value. So. Last but not least, I believe here, I think this might be one of the last slides here, is tracing and part identification. This is somewhat unique, and this is something that I think many people might not have thought about, but when you see what it can do, it kind of gets the thought process and the ideas flowing here. And what we mean by this is, by tracing and part identification, is it's serial numbers, QR codes, and all those types of things that can identify a very specific component, which becomes very important when you're talking about ISO certifications or just various, or even I'm trying to even maintenance and tracking logs. So, for example, if I printed a component that I know has to be maintained every 3 to 6 months, I can put a QR code on there, and when that QR code is scanned, it automatically pulls up a maintenance log, or a technician can instantly say, this is this part, and I've applied these different types of maintenance tasks to it. And the beautiful part about that is, again, can we do that with like a sticker or something like that? Yeah, but you have to worry about the sticker falling off. It's a harsh environment. You have to worry about everybody's been at a grocery store and the bag gets crumbled, or the QR or the barcode gets messed up, and you can't really do anything about it. You got to go find a different product to get that barcode. When it's embedded directly into the product, you don't have that problem. Augmented reality. We talked about how we've been applying that within the engineering process, or the engineering projects that we have. And that's a cool way. You can, by putting certain visual cues into the product, without actually distracting from the product or the design itself, you can apply augmented reality software on top of that, and it can use that for location. It can know what the product is. It can orient it in the correct space. So that's another very interesting one. And we've seen some pretty cool applications of that as well. So, oh, I did have one more. I forgot. User interfaces. What we mean by this is just showing like toolings or jigs or fixtures or assembly jigs, where you can apply color to indicate certain processes or tabs, and it just expedites the workflow in that time. We've been kind of trained, and I was very fortunate to get a lot of Six Sigma training, and there's something called Kanban and those types of things, where you have visual indicators to want to pull from something or deposit there, or use a certain tool in that process, or any of those types of things. Lean, Six Sigma, all that goes into it. And this is a great way to implement those strategies that are proven to provide cost savings in the long run by increasing your efficiencies and reliability. So it's a very subtle but very powerful addition to these types of processes. Wow, I got a lot more than I thought here. This is great. Compliance indicators. This kind of goes along with some of the stuff we've already talked about, especially on the product design side. Many regulatory bodies require certain products or certain parts to have symbols to indicate hazards or compliance with various regulatory bodies. Often ways to do this are, again, post-processing, stickers, paint, any of those types of things, etching. Well, same thing can apply here. We can embed those regulatory markings directly into the part. So just something that might not have been thought about. Wanted to present that. All right, so what I'd like to kind of close out is designing with color. We've kind of talked about 3D scanning and all that type of thing. And there's so many different ways to do it. Contact scanning, light projection scanning, laser pulse, and I talked about photogrammetry already. Yeah, I could go on an entire presentation about 3D scanning, because there's some really cool development and technologies there as well. But the reality of the main thing I want to convey on that is it's much more accessible than it has been in the past, and much more accessible than most people believe or are aware of. Other designing with colors, textures, and stamping. When you're designing a CAD model, you can normally just grab a surface, depending on the software you're using, and right click it. And there's usually some sort of appearance menu, and you can apply colors directly into your CAD model, normally with very few clicks, very few amount of time or work put into it, and you can really change the design of it. The other is called texturing, same type of concept. You can take a two-dimensional image that's already created, and you can apply it or surface it on top of your model. Again, just wanted you to know that it is available. That's a whole nother topic. It's not that hard to do. Happy to help with that if you have any questions about it. Kind of to close out here, and because we did, lose a little bit of time on the front end, so technical glitches. So I'll try to wrap it up real fast. But lessons learned: a little bit of color goes a long way. And think about process consolidation. Don't think about just the aesthetics of it, but think about what you're doing on the back end to really, where color could be applied to just reduce the number of steps within your manufacturing process. I will say, don't force a solution. We have seen on rare circumstances where customers or designers have tried to apply color just because they want to, or just because they need, or those types of things. And even though there are a lot of applications for it, we're also very big proponents of not trying to force a solution that does not fit. And there are circumstances where adding the color might not be adding the value that you would want, or there's just a better way to do it. And we're always wanting to be transparent about that up front. So, and I think that concept applies everywhere, not just with applying full color, but with, just trying to use a 3D printing technology over the other. There's pros and cons to everything. There's a really good analysis that can be played to find out which one best fits. Last but not least, perception is everything. That's one of the things that we've noticed. And looking at this quick little example, these are some test surface finishing samples that we commonly produce. And two things in this sample. One, a little goes a long way. What we mean by that is we did not apply a lot of color, but we added some degree of contrast just by adding the gray and the white. And it makes a very, very big difference. Now, when we give these two particular components to customers, the one that's pure gray, it looks like a prototype. It looks like something that is not done yet. It's not there yet. You give them the gray and the white version. Again, just a small amount of color. It makes a very, very big difference. It looks polished, it looks finished, it looks complete, and people are much more happy with it. So that's it. I know I tried to rush towards the end there, and I apologize again for being a little bit late, but closing remarks is, one, thank you for taking the time to join us here. And then two, just think about it. Think about where color can go in designs, and be happy to help however we can. You can visit us at i-solids.com and contact information there. And final comment here is thank you for TreatStock for putting this on. Awesome to work with them. Great platform, and it's getting better every day. So, all right. Thank you, everybody.